9 inches. That is how much the ocean could rise along the California coast this winter alone. Not over a decade, not over a century, but in the next few months. And that is before you add the sea level rise already sitting there from years of steady warming. Stack those two numbers together and you get something California's coastline has never actually been engineered to handle. NOAA's Climate Prediction Center just confirmed it. A Super El Niño, 95% likely to develop this year. And inside that number sits a second one that should stop you cold. A 69% chance ocean temperatures reach a level that has never once been recorded. Not once. In 75 years of continuous measurement. By the end of this video, you will know exactly why scientists who study this for a living are treating this differently than every El Niño before it, what the actual coastal damage mechanism looks like, street by street, and the one number buried in the modeling that even the researchers themselves called uncharted territory. Stay through to the end, because that number changes what worst case actually means for millions of people living near the water right now. Start with the ocean itself, because everything else in this story branches out from one specific patch of water. Scientists watch one region of the tropical Pacific to classify every El Niño that has ever happened anywhere in the historical record. It is called the Niño 3.4 region, and it is the exact benchmark the entire global classification system is built around. In 75 years of comprehensive record keeping, water temperature in that region has never exceeded 4.5 degrees Celsius above the seasonal baseline, not once. Not during 1982 to 83, the event still studied in climate textbooks decades later for the scale of destruction it produced. Not during 1997 to 98, the El Niño a NASA scientist nicknamed Godzilla because of how far past every previous record it pushed. Not during 2015 to 2016, the most recent Super El Niño most people alive today actually remember living through. None of them crossed this line. This year's models say there is a real chance this one finally does. Think about what 4.5 degrees Celsius actually represents before moving on. It sounds small on paper, almost forgettable, but that number is not describing the air. It is describing the surface temperature of an ocean basin covering millions of square miles, holding enough stored heat energy to reshape rainfall patterns across half the planet. A fraction of a degree at that scale is not a rounding error. It is a different climate state entirely. NOAA's lead El Niño scientist, Michelle Leroux, did not hedge when asked about it publicly. She stated plainly that this temperature level has simply never happened in the historical record. Read that sentence again. This is a scientist whose entire career is built on measuring this exact number in this exact region, using language that flat and that direct. Here is the open loop worth sitting with for a moment. This story is not really about the ocean by itself. It is about what happens when that ocean pushes water directly against a coastline that was never engineered for it. And the person explaining that connection most clearly has spent his entire career cataloging exactly this kind of disaster before it happens. There is a reason researchers keep circling back to that specific phrase, compounding effect, instead of simply saying extra warm. Compounding means the two heat sources do not just add together on a chart. They interact. A warmer global ocean changes how much extra energy the El Niño pattern itself can draw on, which can amplify the very temperature spike that classifies the event in the first place. It is a feedback loop stacked on top of a record, not two separate records sitting side by side. Climate scientist Daniel Swain has built his reputation tracking California's floods, droughts, fires, and storms in granular detail, the kind of researcher other scientists quietly check before making their own public statements. When nearly 6,000 people logged into an emergency online town hall he hosted, he told them this developing system could produce an event California has not seen in living memory. Not an unusual winter, not just a rough storm season. An event sitting outside the range anyone currently alive has personally experienced firsthand. What makes this year fundamentally different is not only the ocean temperature number itself, it is what that number is stacking directly on top of, and this is the detail almost nobody outside the research community has actually connected yet. Every strong El Niño in recorded history developed against a baseline ocean that was, relatively speaking, normal for its own era. This one is different. Global ocean temperatures right now are already running warmer than at any point in recorded history, entirely separate from El Niño, entirely before this specific pattern even started forming. No strong El Niño has ever developed on top of a global baseline this warm before. Scientists have a phrase for what happens when two record-breaking heat sources compound, instead of simply stacking additively, and it is not a comforting one. Uncharted territory. That exact phrase keeps showing up across the research, and it is worth pausing on why. Uncharted does not mean scientists are guessing wildly in the dark. It means the historical models researchers normally rely on to predict outcomes were built entirely from past events, and this event does not cleanly fit inside the range those past events cover. The tool, built to predict the future, is being asked to predict something larger than anything it was ever trained on. This is also why California cannot simply point to 1997 and say it already survived something this size. That event caused billions of dollars in damage, dozens of deaths, and widespread flooding up and down the state. And it developed against an ocean baseline that, by today's standards, was comparatively cool. The starting line has moved. Whatever 1997 proved California could survive is not automatically what this year is testing. Now here is where this stops being an ocean statistics story and becomes a story about actual coastlines, actual streets, and actual homes. Because the mechanism connecting a warm patch of Pacific Ocean to flooding on your street is not complicated, and scientists describe it as close to a near certainty regardless of exactly how the rainfall itself plays out this winter. El Niño's warming causes trade winds across the Pacific to weaken. When those winds weaken, water that is normally pushed away from the coast stops being pushed away. It physically expands from the added heat and piles up against California's shoreline instead. This alone produces a temporary sea level rise of approximately 6 inches along the California coast this year from El Niño's warming effect by itself, entirely independent of any single storm. Now stack that 6 inches on top of what is already sitting there. California's coastline has already accumulated 6 inches to 1 foot of sea level rise from long-term climate change over recent decades of steady warming. Add the temporary El Niño surge directly on top of that existing baseline, and coastal communities are potentially facing total sea levels a foot or more above what was considered completely normal a single generation ago. Here is the part that should genuinely concern anyone living near the coast. That elevated water level does not spread evenly across the calendar year. It concentrates directly into the exact months when California's largest winter storms historically arrive. The extra height is not sitting there quietly in July. It is loading up precisely when the biggest waves of the entire year are scheduled to hit the coastline hardest. Mark Merrifield directs the Center for Climate Change Impacts and Adaptation at the Scripps Institution of Oceanography, and his modeling adds a layer that makes this even more concrete than the raw numbers alone. His research shows dramatically increased probability of high wave events under exactly this kind of pattern. Because the baseline sea level is already elevated before the wave even arrives, even a routine winter storm surge, the kind California has handled safely for decades without incident, now reaches meaningfully further inland than it ever has before. Picture that mechanically for a second. The same storm, the same wave height on paper, identical to storms from 10 years ago, but the starting water level underneath it has been raised. So the wave climbs higher up the beach, further up the seawall, further into the parking lot, the road, the ground floor of buildings that were built assuming a lower baseline. Infrastructure in neighborhoods that absorbed identical storms safely in past decades are now being asked to absorb them again, starting from a meaningfully higher point. It is not only coastal flooding either. Atmospheric rivers, the long plumes of moisture that already deliver most of California's heaviest winter rainfall, tend to intensify and multiply during strong El Niño years. Combine a wetter, more frequent storm track with a coastline already sitting under elevated water, and the two hazards stop behaving independently. Inland flooding and coastal flooding start arriving on the same calendar week. By the way, this is the detail most coverage of this story completely skipped over. The economic modeling behind this event is not treating it as just another expensive winter season. Analysts have flagged this developing El Niño as potentially the costliest on record, with projections suggesting global financial losses could exceed $5.5 trillion once every downstream cost is tallied. For context, that would surpass 1997 to 98, the Godzilla El Niño, an event still considered one of the most economically destructive El Niño episodes ever documented anywhere in the world. This year's projections are not simply comparing favorably to that historic benchmark. They are projecting straight past it. This is not theoretical planning happening only inside university research papers either. San Diego has already convened a dedicated El Niño working group spanning every single city department, coordinating well in advance, rather than scrambling to react afterward once the water is already rising. That kind of cross-department mobilization does not happen for a routine, forgettable winter forecast. And in late July, footage out of Long Beach showed something that tells you everything about how seriously this is already being taken on the ground. Right now, before the storms have even started, workers were photographed building sandbag barriers against flooding weeks before the pattern had even fully locked into place. Not during an active storm, not after an official warning went out, weeks ahead of the season even beginning because the modeling alone was already enough to move people into visible action. Break down what $5.5 trillion in projected losses actually covers, because the headline number alone does not tell the full story. Analysts are counting infrastructure damage, agricultural losses across the drought then flood cycle El Niño produces, insurance payouts, business interruption, and the slower economic drag of rebuilding coastal defenses that were never designed for this water level in the first place. It is not one storm's damage. It is a season-long compounding bill. Here is the bill to the payoff, the part that closes the loop opened at the very start of this video. Remember the number that should never have been possible in 75 years, the ocean temperature record that has stood untouched through Godzilla, through every documented Super El Niño humanity has ever carefully measured. This year's models give it a real quantified chance of finally breaking that ceiling. And separately, scientists tracking long-term sea surface temperature variability have surfaced something else worth sitting with carefully. Evidence increasingly suggests that extreme El Niño events themselves may be becoming more frequent overall, as natural ocean variability increases against the backdrop of an already warming planet. This might not be an isolated outlier year happening in a vacuum. It might be an early look at a pattern that is going to keep repeating. City planners in coastal counties are now running scenario models most residents will never see directly, comparing king tide calendars against the storm season's projected peak. When the highest natural tides of the year land in the same window as the heaviest El Niño-driven storm surge, water levels do not simply add together politely. They compound at the exact moment coastal defenses are already under the most strain, which is precisely the scenario Merrifield's modeling was built to flag in advance. So put the entire picture together in one place. A benchmark ocean region approaching temperatures never once recorded in 75 years of measurement. A global baseline already warmer than at any point in recorded history before this specific pattern even started forming. A physical mechanism that reliably raises coastal water levels by roughly 6 inches, stacking directly on top of sea level rise that is already sitting there. Storm surges reaching further inland than communities have ever had to actually plan for. Economic projections placing this above the most destructive El Niño ever documented in modern history. And city officials already building sandbag walls before the season has technically even begun. None of these are separate, disconnected stories floating on their own. They are one single story, told from 6 different angles by 6 different research institutions that do not coordinate their findings with each other, and still somehow arrived at the exact same conclusion independently. If you live anywhere near the California coastline, or you know someone who does, this is the winter to actually pay close attention to the advisories instead of scrolling straight past them like every other year. The researchers named throughout this video are not speculating for attention or clicks. Michel Leroux runs NOAA's operational forecasting division. Daniel Swain built his entire career on California disaster data going back years. Mark Merrifield runs sea level modeling at one of the most respected oceanography institutions on the planet. When 3 independent experts converge on the same warning inside the same season, that convergence is the actual signal worth paying attention to. None of this is presented to induce panic for its own sake. It is presented because the researchers driving these numbers are the same people responsible for issuing the advisories that actually protect coastal neighborhoods. And advisories only work if people act on them before the water arrives, not after. Subscribe if you want to keep tracking this as the season develops week by week, because this pattern is still actively forming, the numbers are still being updated in real time, and what counts as worst case right now may not still be worst case by the time the storms actually arrive on the coastline this winter. That is the whole point of releasing the modeling this early, months before a single named storm has even formed.